This app looks like ChatGPT. I can type questions or paste in files and images, but the big advantage it has over ChatGPT is it's fully HIPAA compliant. This means I can enter patient information, including their medical history and other PHI, and it's completely safe and legal. To be honest, building a chatbot that functions like ChatGPT is the easy part. People have made tons of ChatGPT clones. In fact, we've actually made a bunch ourselves. The hard part is making it HIPAA compliant, and that's what this video is really about. I'm Chris Malawa, and in this video, I'm gonna walk through what we built and how we made sure that it was fully HIPAA compliant. A little bit of context, we were approached by a medical group to build a HIPAA-compliant version of ChatGPT, and the main use case was so that their physicians could generate follow-up notes with real patient data. But after a couple discovery sessions, we realized that they didn't need all the features of ChatGPT. They just needed us to focus on the actual report generation and then the ability to make simple follow-up edits through a chat interface. So we focused on building something with these core features and making sure that it was fully HIPAA compliant. Before we begin, I do want to demystify two things that I'm frequently hearing when it comes to HIPAA compliant AI. The first is that if I sign a BAA, that means I'm fully HIPAA compliant, right? Services like Microsoft Azure and AWS Bedrock will sign a BAA with you, but just because you have those in place does not mean you are automatically HIPAA compliant. All that it means is that the infrastructure you're using is by nature already HIPAA compliant, but it is up to you to make sure that the way you use it and the systems you build on top of it, the way you configure that stuff, that has to be HIPAA compliant as well. The second is, can't I just anonymize all of the data before it goes into the system? While that is a solution, you miss out on a lot of the benefits of being able to use real patient data. And even if you're doing this, there is still a chance that patient data could make it into that system. If there's any chance patient data could enter a system like this, it's better to just err on the safe side and just be HIPAA compliant. Okay, so now let's dive into what we built. So the first thing we did was actually make a completely non-HIPAA compliant prototype, which does surprise a lot of people because they assume we start with the HIPAA compliant infrastructure and build from there. But in our experience, it's much easier to build without thinking about all the HIPAA stuff. You can iterate quickly, prototype quickly, test UX, just make sure that things are working first and confirm that you're actually solving the right problems. And when all of that stuff is completely proven, it's so much easier to weave in the compliance and the security stuff right after. Very intentional, because the minute you put that HIPAA stuff in place, things do tend to slow down. This infrastructure is complex and there's a lot of considerations when you're building features. You have to account for it. So we prefer not to deal with that while we're actively trying to iterate quickly. With that decided, we kept the scope small and focused on 3 layers. The first is basic note generation. We co-wrote a robust system prompt in collaboration with a physician. That way that the output format was locked to exactly the specific format that they would want. We also added a bunch of validation to try to prevent hallucinations. And that gave us a very good baseline. That way, if we made future iterations, we would know if the system was degrading. Second was the ability to generate follow-up notes. Writing follow-up notes is a very time-intensive task, so this was something that they wanted us to build. So with this feature, clinicians could take an existing note, add follow-up context, and it would generate a follow-up note based on all of that. To be honest, the implementation was pretty similar to the actual basic generation, but we spent a lot of time working with them to streamline what the optimal UX for their workflow would be. The third, which was probably the hardest, was the ability to make edits directly through a chat interface, kind of like ChatGPT. This actually required us to basically build a custom agent. So when you're typing something in a chat and you ask it to make an edit, it's actually an agent, and what it's doing is it's using a bunch of different tools. And the 2 tools that we gave it are the ability to read the report so it can see whatever's in the report, and the ability to make edits. It sounds really simple in theory, but this is actually a pretty common problem. There's actually documentation by Anthropic and some other companies on how they built their editor for their chat interfaces. There's a bunch of ways to do this, but we kept it simple, and we used a search and replace method to power this editing tool that we gave the agent. That was actually really hard to get right. We honestly might just make a whole video on how we build agents like this, because this is a pretty recurring thing that we're having to do, even for something as seemingly simple as a chat interface. Now I'm gonna try to go into some of the details on how we made this HIPAA compliant, but I do wanna note that every application is different. This is just some of the stuff that we worked on for this specific project, but depending on your requirements, you might have to do a lot more or even a lot less. The first step was the easiest. It was to choose a HIPAA compliant AI provider. A lot of people don't know this, but there are services like Microsoft Azure or Amazon Bedrock which host HIPAA compliant version of a lot of popular models. And these are the same models that power things like ChatGPT. And after signing a BAA with a provider like Microsoft, you'll get access to these models and can just use them in your application. But as I mentioned earlier, just signing that does not make you HIPAA compliant. That's just the first step. And it only covers the provider's systems, not yours. We are still responsible for how the PHI is handled, transmitted, stored, and that's where a lot of the focus ended end up being. There are 5 major areas that we look at. The first is overall security, and that covers things like network security. So something that we did was make sure that certain things were behind what's called a VPC, and that blocks outside connections from accessing these services, and only services that are already within the VPC can access each other. Like our database and other services, you can only talk to them if you're already inside of that VPC. There are also some cases where you can take it a step further, like you can put the entire front end behind a private network so that it can only be accessed on premises at the doctor's office or through a secured VPN. Technically, that is not required for HIPAA compliance, but in some case, there is no reason to access these services outside of the doctor's office, for example, and it makes sense to just put those in place. Another part is encryption. So all the PHI has to be encrypted in transit and at rest. This includes when it's moving from the user's browsers to our database to an LLM provider. We made sure to remove PHI from anything that was not encrypted, including certain logs, dev tools, and error traces. The second thing we had to look at was access controls, because even if things are behind a VPC and encrypted, what if some bad actors decided to access those systems? There's a way to preemptively limit the damage that they can cause, and that is through access controls. It sounds basic, but a lot of people don't have this set up. Access controls basically limits the amount of data and the infrastructure that a specific account has access to. So only certain people on the team or certain employees or certain physicians can access PHI, for example. There's 2 basic parts to access controls. It's authentication and authorization. Authentication is pretty basic. It's just how people log in. Is there any multi-factor on the account? There's a bunch of services that will power authentication that are HIPAA compliant. We are personally using AWS Cognito to do this. And with AWS Cognito in place for the authentication, the authorization is something that we implement on our end. So we have role-based permissions, and we added granular control so that nurses, admins, developers, they all have their own role, and they're very limited in what they are allowed to see. A common mistake we see in medical apps is that developers have unrestricted access to the database and the PHI, because technically they do need a lot of this stuff for debugging purposes. That's a red flag. You should still set up your system where the developers or whoever's managing it has access to only exactly what they need. And you could structure this in a way where even if they're debugging something, they should not have access to PHI. There is always a way to do that. Now, there are some instances where parties do need to have access to PHI even if they're not using it. So let's say developers do need to access something that has PHI in it just for debugging, like you cannot get around that. That's where logging and audit trails come into place. Access controls will limit the amount of information that a user can see, especially PHI, but even someone with legitimate access could still perform very malicious actions if they wanted to. And logging and audit trails, while it's not going to prevent it, it is going to capture when this happens. It's going to show who accessed what, at what time, and how much of it did they access. And so if someone is logging in and viewing PHI, that should be logged. If a developer is logging a system that has a lot of access to PHI, like a database, that should be logged too. And even if a developer is just manipulating the resources on an AWS account, for example, all of that should be logged too. There's a bunch of different services that'll handle logging for you, but in our case, we were using AWS CloudTrail and CloudWatch to track certain operations, like if someone was editing something in the AWS account. Storing this stuff is important too, because HIPAA requires that you store some of these logs for at least 6 years and sometimes even longer. So we use services like S3 Glacier to do long-term storage of that stuff. We make sure to sanitize the logs to make sure PHI isn't flowing through, and there's a number of services that Google and Amazon provides to make sure that that happens. With access controls, audit logs, all of that stuff in place, the next thing that's important and often overlooked is documentation. It is the first step in actually just proving that you have this stuff in place without someone having to go and check it. So in our case, whenever we set up systems like this, we make sure to have a lot of documentation on what the systems we have in place, what services we're using for loggings, and then how someone can access these things even if we're not there. Every organization and every application's requirement is completely different, so I definitely consult with a lawyer for your specific application to make sure that you have everything you needed documented. At the end of the day for HIPAA, it's not about just doing the right thing, it's about being able to show that you did the right thing. And the last thing, which is kind of related to documentation, is making sure you have a very good breach plan in place. Again, different depending on the application, but in general, it means having very redundant backups that are encrypted and making sure that they're tamper-proof, which ensures that the PHI is still available even if the database gets completely compromised. We set up systems like GuardDuty and AWS Security Hub to constantly monitor these systems and notify us in case some breach or unauthorized access does happen. This was a very simplified look, and again, it does depend on your situation, but to summarize, first we have general security, and that's going to cover things like network security and encryption. Then we have access controls, which covers things like authentication and making sure that people have exactly the right amount of access and nothing more than they need to. And then we have logging to make sure that if someone was to maliciously access something, that is recorded and we're able to trace back what happened, documentation on how all of these systems were set up, how to access stuff like the logs, and finally what was put in place for the breach protection and what the steps are going to be when that does happen. This was a pretty standard project, and I hope it emphasizes that HIPAA compliance is not just about signing BAAs. There is a lot of stuff that goes into it, but when you look at it from a high level and you look at all of the layers, it's actually a very standard and repeatable thing that you can do for any application. I really hope this was helpful. We will probably be making more videos going in depth. If there's something specific you want us to cover about any of the things that we talked about, please let me know in the comments. If you're interested in building AI applications, especially in the medical space that are HIPAA compliant, check out our other videos. We talk about testing, we talk about model selection, really good resources. And if you want to connect with someone to talk about building AI applications like myself or anyone on my team, I will also leave a link to contact us below as well. But thank you so much for watching, and I will see you in the next video.